So good morning. It's a good start. The audio works. Good morning. I'm Iain Davidson, Product Marketing Manager at Wireless Logic. Wireless Logic is an IoT solutions company. We provide IoT connectivity, but a whole series of services we wrap around it to make connections more reliable, more flexible, more secure. We want to talk today about our Defend, Detect and React framework. These are the three principles we've embedded into an IoT security framework, which we use with our customers and prospects to help them assess and address IoT security risks with a 360-degree or an all-round approach. IoT security is always, or security generally, has always been a concern, always been a risk in life and in business and in technology. Traditionally, security has been addressed using some pretty well established and good best practices. But we now have governments in the UK, in the European Union, in the US and further afield, developing legislation programs, or in the UK have signed off legislation that mean pretty soon there'll be a legal obligation on businesses to comply with IoT security standards. So what used to be voluntary or best practice based is going to quite soon become a legal obligation. So quite a game changer, right? And I'm going to talk through these four stats. These are just stats that I've cherry picked from a million stats that are out there, just to try and layer up a few key messages. So the first one is a bit of a nuclear type message, isn't it? It's like 1.5 billion IoT cyber attacks per year and growing, measured by Kaspersky. It's a year or two ago, but these threats are out there. Of course, it's a bit more nuanced once you get into the details, and Verizon published a report quite recently. They're a US company, obviously, but this is a global study that they've done. And the message they're passing is that the primary motivation behind most cyber attacks is financial gain, and it's conducted by cyber criminals. It's not the NSA or GCHQ or China or Russia, cyber criminals. And the preferred tactic that they use is ransomware or a denial of service type attack that they turn off and turn on depending on a ransom kind of deal that they're making. And the reason they choose these approaches is because around 60 to 70% of companies actually pay ransom demands quite quickly. What they're thinking about at the time is, it's going to cost me 50k or 100k ransom to get this resolved. Or I try and rebuild my system from backups, and that might take me days, weeks, months, and cost me millions. So most companies these days are rehearsing ransomware situations, but they have a plan, and they have a policy. They might even have insurance. The fourth stat on there is, I think, quite an important message here, because we're a technology company, and I guess a lot of you guys are working in technology, I'm guessing. But 3/4 of most security breaches have a human or process type element. Cyber criminals usually build up information about their targets using in multiple stages, and often the very first step is a human weakness or a process not being followed or a shortcut being taken. So people and processes are just as important as the technology themselves. So we're going to use some real world, and this isn't a name and shame sort of moment here. Again, I'm just using some cases that are sometimes quite well publicized just to illustrate a few points here. And the first one is the Colonial Pipeline Company. So this is a pipeline operator based in Houston, Texas, distributes oil and gas around mostly the southeastern part of the United States. But they had a ransomware attack in 2021, and their reaction was to shut down the management systems on the pipeline. And that meant there was no fuel flowing. That meant fuel shortages. That meant panic buying in the streets. So there's a real national situation, crisis, if you like, there, where probably half the United States of America wasn't getting fuel for a week because of the ransomware attack, and because Colonial hadn't really rehearsed or figured out how they would deal with that situation. So they paid. In the end, they paid. And I think they've eventually started to get some of that money back. But anyway, Rossetti, next one, is an EV charge point operator in Russia. And they had an attack on their EV charge point network in the highway between Moscow and St. Petersburg, which meant they were out of service. There was also anti-Russian propaganda displayed on most charge points of a screen these days. There was anti-Russian propaganda on there. So reputational issue, loss of revenue, loss of service, and quite embarrassing for them in the sense that they eventually tracked down the culprits behind it, and it was a Ukrainian supplier that was behind it. Yeah. City of Johannesburg is the next one, and that's quite an old example, but it's a case of an inside job where insiders inside the city council have stolen SIM cards from traffic light systems. And in the process, the traffic light system is down. They then use those SIM cards in other devices to stream, let's just say Netflix, stream other stuff. Right? So that's obviously put the traffic lights out of the system and created a large bill for the city council. These are things that we can help companies detect. This is easy stuff. Right? They can detect removal of a SIM and misuse of a SIM. It's easy to do. But only if you know who to talk to and who to partner with. So along the bottom there, Target is a large US retailer. They had a lot of data stolen, customer information, credit card information stolen. There were fines. They had to declare it. The law requires that sort of stuff gets declared. They face fines as a result. But they had an even bigger cost to try and identify the source of that. Now, the source turns out to be a third-party contractor maintaining their heating and ventilation systems. It was connecting into the network using VPN, but there was no multi-factor authentication on it. And there was details stolen from that, and the hackers get access to it. People and processes, part of it. I know I'm moving really quickly here, and I'm not naming and shaming. I like Spotify, I'm a customer, but this one's my favorite, if I can put it that way, because organised crime have uploaded fake tracks onto Spotify, 21 seconds long, because that's how long a stream is in the Spotify charts. And they've got a bot farm just constantly downloading these tracks. And so the Spotify account, counts up the streams. There's obviously it's a huge proportion of streams now paying out to the organised crime and not to genuine content providers. This is something in the media industry, so it's not well publicised, but we can share the links to these things. But it's not a name and shame thing. The point here, I'll circle back to this example a little bit later, that's something that can be detected and managed with software in an automatic way. Mirai Botnet's the last one there. I put the Airbnb logo on there because they were one of the victims of it. Mirai Botnet is a piece of malware that self-propagates and directs denial of service attacks against servers. They attack Airbnb and Netflix and a whole bunch of other type companies. Again, I'll circle back to the Mirai Botnet a little bit later. I want to introduce our framework, and it's built on these three pillars of defend, detect, and react. And now, Wireless Logic, we've been working in the IoT business for 20 years or so. We've built up a lot of experience in working with our customers, a lot of insights that we've started to build into, yes, our products and services, but also in the form, build that into the advice that we give to our customers and prospects as they are trying to deal with IoT security. So yeah, the framework covers technology, as I said, but also helps businesses think about people, processes, and systems, and they need to rehearse and practice for these type of situations. So we're going to talk segment by segment, not one by one. There are 16 provisions there, but we're going to talk segment by segment in a little bit. But we've based this in part on our experience, as I said, but also on other industry standard approaches and standards that are out there. So if you looked at Etsy, EN 33645, I think it is, then it would look familiar. If you look at in the US, in the NIST standards in the USA, again, you'll see some similar things, but we've taken a secure connectivity lens on it, so it's tailored towards the customers that we work with and how we work with them, the type of problems that they have. And as I said, there's 16 provisions in total. And we're going to look at them one by one. And the first one is about managing identity. That's of primary importance. I mentioned the Mirai botnet earlier, and the Mirai botnet was successful because attackers were able to guess passwords. Because a lot of devices then, this was 10 years ago, but even now, are shipped with universal default passwords. And that just allows customers to learn once and apply it everywhere, or just guess. And this still happens. Probably we all do it as individuals as well, with all the different apps we've got on our phones and things like that. It's a tough one. But for IoT devices connecting to cellular networks or to cloud networks, identity comes in the form of pre-shared keys, or maybe and probably certificates, which are used to establish DTLS connections with cloud service providers. Now, these days, the SIM is what you use in your bank card to authenticate you as a user, a customer. It's what you use in your mobile phone to identify you as a subscriber to that network. The same thing can be used in IoT. And these certificates and pre-shared keys or PKI type of setups can be supported by the SIM. It is a secure element in its own right. You pay for it already. Why not use it in that way? So identity is super, super critical. And when I'm talking about the SIM here, I'm not talking about something proprietary or weird. It's a GSMA standard. So take confidence in the fact that there is a standard. It's a service we can provide you with, and others, and it really solves this identity challenge big time. Just takes it out of your hands, automates it, and reduces the number of touch points that you might have in your supply chain around these data. We'll circle back on that a little bit later, do a bit of a deep dive. But then moving round is the segment, and the defend segment. Defend is the biggest chunk of the framework, you will have noticed, and for good reason. So beyond the identity piece, there's a series of sort of mandatory things, I would say, that you should be thinking about and building into your products if you're an OEM or a product developer, or if you're, let's say, a user, an enterprise-type user. You should be insisting that your suppliers are providing these sort of capabilities. So yeah, mandatory things like secure communication sounds obvious, right? But resilience, keeping the network up and reducing the number of outages and the amount of maintenance situations you may have to go through. And then managing software updates. I know these days that's quite normal, but not always. So in terms of secure connectivity, we're talking here about things like private networking, techniques using private APNs, VPN type technology. They're pretty standard type capabilities, not difficult and not overly expensive to implement if you work, again, with the right partner. Resilience, that includes things like geographic and network redundancy with automatic failover. That's true of the networks, it's true of the connection, and that type of thing. And again, standard features from most cloud providers and most network service providers like us. But again, what about the people and processes and systems? If we move around the wheel again and now talk about detect. Stuff happens, and it's going to continue to happen. And while we can provide a series of measures, cyber attacks are always evolving, and I don't think anyone can really guarantee or rest thinking that they've solved this. So having a good detect strategy is important. As I say, stuff happens. There's a firm, UpGuard, a well-known security analyst. They estimated that the time taken, they consulted, they surveyed, not estimated, and the time taken, the average time taken from breach to detection is 200 days. It's about 7 months. Can you imagine what can be stolen or the damage that can be done if you've got someone just rooting around inside your network and accessing your data? So detecting breaches quickly is clearly fundamental to protecting your customers' value or even your own business value, your own reputation. And we do that in a few different ways. So we can monitor device behavior. So that might mean how regularly it's communicating, where it's communicating from, what the environmental measurements are around that device, if that's available, might be a factor. At a device management level, again, there's another layer of things we can monitor and automate, but we can also monitor at an application level. One of the services we provide is a platform called IoT Solutions that helps customers build applications really quickly, but also helps them model and understand how their entire system can behave in different conditions. And that includes security and looking for anomalies and automating reactions even to that anomaly. So it's pretty smart. And it's key. As I said, it's the time taken between detecting and reacting to that breach is really, really critical. So use automation. I hesitate to say AI, but it's on the slide there. I've got to say it. Use a bit of AI. And then naturally, the next part is reaction. So, what steps do you need to take? And a little bit ironically, the ability to react starts at the design stage. How you react to something you need to plan for, you need to rehearse. And it depends on how well you understand your system and how it behaves under sort of corner case type conditions. So I mentioned rehearse. So consult with organizations, right, who can help you probe your systems. This might not be applicable to all of you, but it might be advice you give to your customers as well. Rehearse, simulate, plan. And we do this, right? We do this. So we did a ransomware simulation event recently, where we had, and it's a training. It's a training thing as well as a test of our own networks. And it went through the scenario I just described earlier. The team had to get together quickly upon detection of the ransomware attack, which might just be an email from someone, right? But where does that email go? And if it lands in your own inbox, what the hell do you do with it? Who's responsible for this sort of thing? And then how do you handle it, right? And one of the steps we've taken was to look at ransomware insurance. The whole industry out there who do pay out. So yeah, rehearse. And as I said, I touched on it earlier, modeling goes a long way to really understanding how your system's going to react. IoT Solutions is part of our capabilities that helps look for anomalies in normal behavior. So that's been a really quick flow through the framework, obviously. Now, we do have a brochure here. And it's an overview, right? It's an overview. It's here, so come grab one. Or we're on stand 15, which is really just through the wall there. So really handy. Come and talk to us. Or come down the front and grab one of these at the end. But it'll help you take these thoughts away and consider whether they are right for you or your customers or not. But ultimately, the framework's designed to promote a sort of continuous, iterative, 360-degree assessment and improvement of security. Promotes adoption of the best practices, like XA, like NIST, but it promotes investment in people and processes. I can't emphasize that enough. Now, ultimately, it does draw upon products and services that we provide. But where appropriate, we'll draw upon partners in our ecosystem to provide other type of support and help. So our security stack is on the right-hand side. I had to check there, right-hand side of the slide there, and I'm not going to touch on all of it. We don't have time today, but it goes from Cloud Secure. Cloud Secure is our name for our IoT Safe, which is GSMA standard that manages identity. I spent a moment on that, and I'm going to pick up on again in a minute. But it goes through SIM and device management, SIM-Pro, NetPro, Device Pro, to anomaly detection tech capabilities. We're going to spotlight that in a moment. I've used the words already. I'm going to explain what we mean by that. IoThink solutions I've touched on. That's about digital twin and modeling and reacting to strange behaviors. And then that time to react really relies on systems, of course, but also people, 24/7 global operations, sort of thing that we provide as well. So real security stack capability there. It doesn't directly map into all of the provisions. We don't do everything. We're not pretending to, but we can refer you or your customers to a partner if need be. So again, flying visit. Grab the brochure if you want to kind of take it away and reflect. And I suppose this isn't the end, but I want to kind of wrap up this portion of the presentation by just leaving three key messages, and it's a little bit of a repeat, but just for impact, hopefully, three key messages. Number one, it's to assess the safety and security impact of your data and implement security accordingly. Because what I'm not actually saying here is you need to take all of that stack that I just showed and it applies to you and you should use it. It's not what I'm saying. You've got to think about it. We've got the capabilities there. Some of it's going to be spot on for you, but others you might decide, hang on a minute here, the data my IoT devices produces, it's just not that safety critical or security critical, or the wireless connection I have means that streaming from Netflix is just not physically possible. So you'll choose the right sort of approach according to the economics or the technology around your device. Number two, leverage partners. Don't try and solve this all on your own. I've confessed already, we leverage our partners as well. But yeah, leverage them. Choose a small, trusted set of partners and just leverage them to keep you up to date on the latest technology, legislation, and best practices. And then don't forget, embed security in the culture of the organization. Design for security. Design for detection and reaction, because you're the end users, whether it's an individual, a consumer, or an enterprise, are going to appreciate it. And remember, it's going to become legislation soon. It'll be a point of differentiation. All right, so I promised a couple of times to do a little bit of a spotlight on some of the capabilities that I've spoken around in the defend and the detect sections. And I'm going to do that now in the next 7 or 8 minutes, and then we're going to stop for questions. So defend, I said, managing identity, I said, is really key. It is. That was the reason the Mirai botnet was so successful. And identity can come in a number of different forms. It could be a hardware identity. For those of you working with cellular connected devices or using a cellular module, you'll recognize, hopefully, the IMEI number that's allocated to define your hardware. It might be a SIM identifier. It might be an IP address that in our world we normally provide, a private, usually fixed, sometimes dynamic IP address. It might be pre-shared keys, or you might be having a PKI sort of setup where there's public keys, private keys, certificates, all in the mix. And then, so depending on which of these elements you're using to identify your device and authenticate your device onto the mobile network, usually where we sit, or even onto a cloud or a server type of environment. It'll depend which you use. Key thing is, though, this new legislation and the ETSI 3 605 standards. Well, right now it says recommending. That's going to pivot, right? That's going to be more of a requirement. That'll be more strongly worded. But these credentials, right, are stored within a security certified hardware-based secure element. Might be in a microcontroller. Some of them have that. But the SIM is there, right? So the GSMA standard, IoT safe, means you can use the SIM for this purpose. And so I've done a little, comparison between using the SIM and some other approaches against these criteria. So the great thing is using the SIM, it's an open standard. Not always the case with some other approaches. And it's security certified. So the way in which the SIM is manufactured, the certificates are embedded within it. Remember, same industry supplies the bank cards, supplies the mobile phone industry, it supplies the IoT industry. So it's security accredited, security certified, EAL4+. That's where it needs to be. The processes for managing a SIM remotely, same thing. They're also security certified and accredited. And then cost. Everyone always asks about cost of this sort of approach. But you're paying for the SIM anyway. There's a small incremental cost to you or your customers to take advantage of this capability. Seriously worth a look. And then in terms of ease of use, much, much easier process of using that approach versus some other non-standard approaches. And just to illustrate that a little bit, I'm going to quickly show you a high-level stylized schematic, not very technical really, but we can't avoid the technology completely. But so, things that we connect, and, a simplified view of a sort of stack, application stack on those devices on that side. See right at the very bottom, there's a SIM with a little applet on there. And this is where the security certificates and keys can be stored and embedded. We had some customers in the past trying to address this problem that maybe had an embedded flash in there that they used to store the certificates, but the way in which the certificates were embedded in that device was they were emailed to a third-party contract manufacturer. Now there was I don't believe there was ever an issue that they ran into. But that's a risk. That's a third party and involved in handling certificates and installing them on devices. So, using IoT Safe, the certificate authority is down there, bottom, middle, and the certificates and the keys are loaded in the factory, provided by us, of course, but we don't touch that stuff. We don't touch it. We might ship to you, or you might receive directly from the factory. And so the keys and the information are in here. So taking a lot of risk and really simplified that part of the process. And then when the device attempts to connect, for those of you that know PKI really well, you'll recognize a sort of client-server certificate authority type three-way relationship there. But the key simple message is device-to-cloud connection happens much more automatically, and the phrase we use is zero-touch provisioning. And essentially the server, on the server side, the cloud side, it's more or less expecting a connection from a device. And it knows the identity of it already in many cases. And it's just much more portable, much more autonomous, and there's just fewer touch points in the whole process. So it's seriously worth a look. Clearly there's detail behind all of that. We haven't had time to get into it, but hopefully I've given you a feel for the benefit and the value that it offers IoT Safe. And then next, just a couple more minutes probably on detect. Remember, the time to detect a breach is directly proportional to the costs and the damages and the impact, the downtime that you're going to experience. So constantly monitoring your system as part of this. We've got an anomaly detection capability, and it includes the ability to detect and block cases of SIM theft or misuse of SIMs. Right, that City of Johannesburg example that I spoke about earlier is a classic case of that. That's easy for us to detect. Got to work with the right partner. So SIM theft usage in unauthorized countries or unauthorized streaming services, such like. But this malware topic is a trickier one for many, but there's hope. In fact, I should just touch on the Spotify example at this point in time before we just move on there. So if you break that scenario down, then what it looks like from a network perspective, from our perspective, is you've got a number of endpoints constantly streaming a small number of tracks on a continuous basis. It's quite easy to spot if you know where to look. If you know where to look. Let's hold that thought and we'll come back to it. But malware more generally, and I've just listed a few common examples of malware or ransomware type of tactics, tools, threats, if I can put it that way. But the key message in it is that malware does leave a trail. Just like the Spotify example, there's a trail, there's a pattern there that can be detected if you look in the right places and look constantly. Malware leaves a trail. And the trail is because malware will almost always check in with a server, a malware server at some point or on a regular basis. And it will do that because it maybe wants to propagate. It maybe wants to update the malware. That stuff's smart, right? So it's contacting a malware server. That's something that can be detected because that server won't be in an approved list of IP addresses that we would normally work with you on to define up front. And it's also maybe performing, this is too many spy novels I've been reading, data exfiltration, stealing data, right, and uploading it. It's more dramatic to say exfiltration, so I use it. But data exfiltration, so it might be a different server, but it, again, won't be an approved server, and it's something you can detect. And our anomaly detection engines in our network are positioned to look for these type of anomalies, if I can put it that way. And a really simple diagram, slightly more complex one in a second, but really simple diagram just to emphasize that. So normally, the things we connect are here, and the normal sort of behavior is that they communicate with this green server on that green path. And on that server, there's an application stack, of course, there's probably a firewall, and that's fine. It will receive and process and handle the information from the device fleet or from other sources, right? It's not always about these devices, right? But, keeping it simple in the beginning. And it won't see malicious traffic at all unless there's a direct attack on it, which could happen, has happened. We've gave some examples of that previously. But yeah, what it won't see is our malware on devices or other nodes in the system contacting third-party servers, whether that's conducting an attack on them or whether it's streaming from Netflix or some other service. And what you won't see in the green cloud is that sort of traffic. We touched on it before. Malware communicating with its server or exfiltrating data, stealing data. You just don't see it unless you look in the right place. And there's a clue right in the middle of the slide there. And again, similar sort of one picture that we looked at before, devices here, your customer or your server or cloud is on the right-hand side. In the middle is the stylized view of our network at Wireless Logic. We've got our own mobile core network dedicated for IoT. We call it Connexa. That features there. But the key point for today is at the bottom. We've got anomaly detection engines that are constantly monitoring, not payloads. We never look at payloads, but we're looking at the traffic stats. We're looking at the metadata, if you like. Not in real time, but it's near real time. And that can be deployed in different ways. We can host those engines on our server or in yours. The model can be SaaS or not. Let's leave that detail for another day. The point is, we're constantly, it's not in the data path, but it's offline and monitoring in near real time. And we can alert our customers, your customers, to these sort of anomalies that we've just described. So the tools are there. I've just chosen a couple just to highlight today, and I'm going to pause now. I'm going to be 6 or 7 minutes for questions. Hopefully, though, I've not worried you too much. I think the threats are there, the legislation is coming, so you need to think about it at some point in time. But talk to the right partners, work with the right partners, and you can absolutely improve how you manage IoT security in your devices or your customer systems or whatever. So this is me, there's my email address, webpage that has some additional content that we've just walked through today, and don't forget the brochure's here, or you can pick it up on stand 15. But yeah, we've got 5 minutes or so, 6 minutes for questions if you guys have any. Yep.
No mic at the shout.
There is one, it's just coming. Thank you.
Thank you for the presentation. Apparently, you advocate to adopt a GCMA approach in the framework. But then in one of your slides where you compare IoT Safe with the proprietary solutions, you say IoT Safe is good and proprietary has many challenges. Now then, if you look at many vendors, Honeywell and others in OT space, they all, well, most of them use proprietary solutions. And how would you estimate the amount of IoT safe secure devices out there in the world comparing to proprietary landscape and devices?
Yeah.
And it seems to me that majority are still proprietary systems.
Today, yes. So IoT Safe is relatively new. Relatively new. And in some ways, it's a reaction to the fact that there are, as you described quite rightly, a number of proprietary solutions and implementations that are out there today. ARM and Intel partnered us a while back, and I don't know if it's still a real thing, but they partnered to try and address that type of problem. In my past, I worked for Freescale Semiconductors, and we produce, or Motorola Semiconductors, if I go way back, showing my age. But yeah, even at that time, we were talking about blowing fuses and processors to create a hardware identity. But that's very difficult to scale and very difficult to repeat that process across multiple architectures or components that you're using in your system. And what I'm just describing with IoT Safe is more standard. It's very portable across no matter what device you use. And even if you don't use a cellular connection, you could still take advantage of a pretty low-cost component there, and it's a very standard way. And the process, remember, for embedding these security credentials is fully accredited, fully secure. It's the same supply chain that bank cards use, mobile phone industry uses, etc. So I think it's really worth a look. To your point, there are other solutions out there, but they are proprietary. And I think sometimes, I think we've all seen it, you come up against, you try and pitch a proprietary solution, and yeah, it might be super differentiated. Even then, you still have perhaps a customer that says, I love it, it's beautiful, but I don't have a second source. So IoT Safe, well worth a look. It's less mature than others that have been out there, but it's standard, and it's open, and it's not proprietary. That's my argument. We can arm wrestle later if you're unsatisfied.
Sure, yes.
Any other questions? Got a few minutes. Oh, not photographs. So I need to stop and smile. Sorry. I thought it was a question. Sorry. Yep. Go on. Thank you.
Okay, 2 minutes. Can you expand a little bit on the ecosystem of partners that are involved in the different elements of that framework? Because it's quite complex, I'd imagine.
Yeah. So difficult to get into all right now, but give you a couple of examples, perhaps, right? So, yeah. It says 1 minute left, so let's use that minute. So, for example, we're a software services SaaS type company, right? At the end of the day, some of our customers are maybe more embedded developers or developing products. They want to understand maybe, what are the what's the best operating system that I should use, and how should I configure that, and how do I integrate things like a secure SIM, an IoT safe SIM. So, you know, there's more an embedded part of it, and that's not our strengths, right? There's an overlap for there, sure, right? But we would work with a partner who can come in and train, give that type of training, and work with the same partner probably. And in fact, if you get onto the webpage, it's still there, you'll see a blog from a chap called David Rogers, who chairs the GSMA security on security and fraud. But he's also the co-founder of a company called Copperhorse, who can do that type of thing that I've just described, who can work with you on what is your ransomware strategy, what should it be. And there are other partners in the ecosystem that would do that type of probing, for example. So just a couple of examples, and getting a signal from the back. So, but come talk to us at Stand 15, please, if you want to pick up on that. It's a very partial answer. We've got to go, I'm afraid. Thank you.